In this video, we'll look at advanced queries, views, and subqueries, and why we need them. Some questions are more complex. We can't easily answer them using a simple query. For example, comparing numbers to calculations when we're running a query, or finding not matching records. In inner join, we'll look for records that match a criterion. But then sometimes we're going to see which records are not matching any of the existing records in the other table. Examples include comparing values of one field to the statistics of the same field in the same query. When we're running the query, we are comparing, for example, the individual numbers to averages of the same column. We need to calculate that average, hold it somewhere, and then compare individual numbers one by one to that number and return results. Or which inventory items have not been sold yet. We can use nested queries, query within a query, saved views, which are queries saved for reuse in other queries, outer joins, left join and right join, and additional keywords that we'll see in this video. For example, which computers sold for more than the average sale price of all computers? Here we need two tables. For the computer, we need to look at category, as in item table. For the sale price, we need to look at sale item, see what's the sale price there. And for the list price is again in item table. So we need these two tables. We start running the query. Select distinct. Well, distinct will prevent repeating records. Returning the stock keeping unit, the brand, and sale price from the join of these two tables. Here we need to compare the sale price to a number, the average, and we can return that average using a query. And that query, called as a nested query, is within a pair of parentheses because we're starting a new query within the main query. Selecting that average number from the join of item and sale item because we need the category, it must be a computer, and we need the sale price. Once this average is calculated, then it's part of the criteria we're using, where sale item dot sale price must be greater than this number. And this subquery will help us to return the right answer. And then at the end, for the main query, we need to pass this information. The item we're looking for must be a computer, so additional criterion, item category must be a computer. For this question, count the number of orders for each supplier, including a supplier with no order. So if we use inner join, we will automatically filter out the supplier which exists in the database, but we've not sent an order yet. A different kind of join will work here. Which tables are involved? Well, the two tables we need if you want to return information about the supplier: a supplier table and merchandise order. In merchandise order, we have the track of supplier ID, which shows if a supplier has received order, and then a supplier company, first name, last name. So we start the query by select statement, company, first name, last name, and then count of purchase order number. We join the tables using a left join. The left join is a kind of outer join between supplier and merchandise order, and how it works. The table on the left, which is the table we first put down in this query, supplier. There are two tables on both sides of left join, supplier and merchandise order. Merchandise order is on the right side and supplier on the left side. So the first one, supplier, this query will return all records, even if there is no matching record in that table. So all records from supplier and only matching records from the other table, the merchandise order. And then since we have aggregate function, group by supplier first name and supplier last name and company. If we look at this result table, we'll see that we have one supplier with 0 orders. So definitely we don't have any matching record in merchandise order, but we retrieved a record by using a left join. We do have a different way of retrieving that information, which retrieves only the supplier with no records. Selecting the same fields And then in criteria, where purchase order number is null, because left join will retrieve all the supplier data, and since we don't have any matching purchase order number, it will be null, and this result will show only that supplier. Left join can work with more than two tables. For example, if you're going to retrieve a list of all suppliers and their items, the query will join all four tables that are involved. To include suppliers with no order, we can join the three tables, merchandise order, order item, and close them in a pair of parentheses, and then do a left join with supplier. And how to match the supplier? Well, the supplier has a relationship with merchandise order. We do a left join between supplier and merchandise order, and it will retrieve the list we need, including supplier with no orders. Which items were not sold? We can easily retrieve a list of items that are sold with a simple query. Well, not sold, we need to use the keyword not in. We can select all stock keeping units, category and brand from item table, where that stock keeping unit is not in a list that retrieves all stock keeping units. So a nested query, the second query, as we see, selects all primary keys of sale item from sale item table. These are the items that are sold. If there is a stock keeping unit that is not within this list, that belongs to an item that was not sold. First question. Black Friday sales of 2016 were from November 20th through November 27th. Which computers did not sell at all through these days? Well, one more time again, we have a similar query. We need to look for computers which their primary key, the identifier stock keeping unit, is not within the list of all computers sold in those days. So we start with a simple query. We select all stock keeping units from item where that primary key is not in a list. That list is returned through a subquery, a nested query, which selects all computers that are sold within those days. Of course, including a criterion for computer within the nested query is optional. This nested query returns all items. Then if the computer primary key is not within them, then that's the computer that is not sold. So what's important is that we add that criterion to the main query. So the last line after we finish the subquery is to determine the criterion for computer. Item category must be like computer. Now a similar question, a little bit more difficult to answer. During the same days, Black Friday sales, which computers sold more than the average sale price of all computers through these days? So what we need to do is looking at the computer sale prices and then retrieving the average sale price of computers during the same period of time, and then see if there's any computer that sold more than the average. Well, there is definitely a list of them. So we need the tables sale item for the sale price. We need item for category, must be computer, and then we need sale table for date. We have the criterion sale date between those 2 days and category computer and sale item sale price must be greater than that average. That average number is returned through a nested query. And for retrieving average sale price within those days, we need the same three tables: sale item and sale item. Sale for date, item for category must be computer, and then sale item for the sale price. And putting down the same criteria, must be computer and sale date between those 2 days. Now, how to use a saved view. Saved view is a saved query. We use a query, and usually we do this when we need to use that query again as a query or as a subquery in other queries. If we use a query multiple times, that's better to save it as a view. We don't need to save all queries as views because we can easily create lots of views and then being lost. The best thing we can do is to document them. If you create a view, document them in two places: as a comment on top of the query, and keep the document somewhere out of the database system so that you know what those views do for you. For example, here, calculating the average computer sales. We can use that same subquery as an independent query and save this as a view, and then reference this in the main query. A saved view will perform exactly like a table. So that's a virtual table. And then in the main query, run the main query similar to the same main query we had before, but we reference that saved view. Here we have in criterion sale price greater than. Here, rather than creating the query again, we just referenced, select everything. Well, that subquery or that saved view retrieves only one number. So select everything, retrieve that number from computer sale average. This is the name we put down for that saved view. If you're going to put a time interval on the results we are retrieving, for example, that's the same date, we're looking at the database and we want to retrieve the list of sales since last year for a complete year, 365 days. The syntax is different in MySQL and Access. Select everything from sale date greater than. Well, this is syntax for MySQL. Date add. This is a function with two arguments. The first argument is a date, CUR date for current date, and no argument. This will retrieve the current date. And then keyword interval, how many days we're going back, negative 365 day. It means go back, the time interval is 365 days until today, and retrieve what we asked. Select everything from sale table. Doing exactly the same thing in Access, the keyword is different. So the first line is the same, select everything from sale table, where sale date is greater than a specific date. In Access, date would retrieve the same date, minus 365. In this next example, we're going to retrieve a list of sales by category as a percentage of total sales. So each category, we'll look at that, what percentage of the total sales belongs to TVs, to computers, to other categories. Here we can use a saved view to make it easier, selecting a category and then doing the calculation, adding up all sales from sale item table, quantity times sale price, and use the sum function to add up all these as sales subtotal. And the data we're looking for is in two tables: item, which holds category, and sale item for quantity and sale price. So we'll join these two and then group by category. We will save this as sales subtotal view. And then the main query. We will retrieve category from the view, sales subtotal from the view. This is for each one of those categories. And then do another calculation. Divide that sales subtotal by a number that calculates all sales. And that's a simple query. Use this as a nested query. Select sum of quantity times sale price from sale item. This is regardless of the category, just total sales of everything. This ratio is the ratio of category by all sales. And the only table we used for this main query is sales subtotal view. And this is the result. Percentages show up as decimal numbers. We can show them as a percentage. So we need a little formatting. If we use the same query, same main query, this entire calculation, we put this in a function, concat. That's for concatenation. We can connect different strings using concat function. Well, the first part of the calculation, sales subtotal, retrieve that, multiply by 100, because we're going to show them as percentage. Multiply by 100 divided by the same subquery we had before, and then put a comma down. That means we finished the first argument, first piece of concatenation here. The second part, percentage sign, and then use as, put a name down, percentage sales from the view. What we'll see is percentage sale as a percentage. Now, if you're going to format them with only two decimals, for example, there's a way for doing that using the same query. Within the concat, when we do the calculation, we can use format function. So put the entire calculation in format. That's a function with two arguments. The first argument of format is the entire calculation, and then after a comma, the second argument is the number of decimals, 2. And then we'll continue with the rest of the concat function, put down the percentage sign, and the rest of the query. And we'll see we have only 2 decimals. What is on-hand inventory of each item? Well, on-hand inventory is a difference of orders and sales for the item. So we need to calculate the difference of them. Here we can use views. We can save 2 views. First, look at the tables. We do have item and sale item. In sales view, we add up the quantity sold for each stock keeping unit. So that's a simple query. We prevent repeating sales of the item by using distinct stock keeping unit and then add up the quantities for each transaction. So we'll add up all those units sold for each stock keeping unit from the join of these 2 tables, item and sale item, and group by item stock keeping unit. We'll save this as sales view. And then orders view, item and order item. How many units were ordered? We do something similar, adding up all quantities of order item for each one of those stock keeping units, and save this as orders view. And then in the main query, we'll retrieve the item primary key, stock keeping unit, and the difference of these two, orders from orders view and sold from sales view, they must match for each stock keeping unit. So we'll calculate the difference of these two for each unit as inventory. We can combine lists using in. For example, customers who purchased TV in January and camera in May. Which tables are involved? Well, we need the customer data, first name, last name at least. Sale date, TV in January, camera in May, so sale date is required. We need a category, which is in item table, and then we need to match all these records. So sale item also should be involved. So we need to combine the lists. We need to come up with a list of customers who bought TV in January, then see which one of those customers who bought camera in May are in the same list. So that's a relatively long query because we're joining 4 tables. But here we're creating a list of customers who bought TV in January. The month of sale date equals 1 and item category is TV. And then customer ID in the next list. In pair of parentheses, we have a query that retrieves the list of customers who bought camera in May. Month of sale date is 5 and category is camera. If the customer ID is in this list and the customer is also buying TV in January, then will be included in results. Did any camera sell for more than a freezer? Here we need to compare, and then the keyword that can help us here is any. First, we can create list of cameras sold, and then we use distinct keyword to prevent repeating records. So we need the tables sale, sale item, and item. We join them, and then category must be camera. Sale price greater than any. It means any of the numbers that will be in the next list. And what's the list? That list will retrieve by the nested query. Selecting the sale price for all freezers. Category must be freezers. That's the only criterion here from the join of the same tables. And the result will be cameras that are sold more than any freezer. So if there is even one freezer sold for less than a camera, that camera will be in the list. I will continue this discussion in the next video.